everyone, and welcome to theCUBE's live coverage of KubeCon CloudNativeCon EU. I'm your host, Rebecca Knight. We are live in Amsterdam, and I'm sitting alongside the tremendous Rob Strechay. This is not your first KubeCon.
No, not my first rodeo in the least.
No.
But, I don't even remember how many in a row, but it's been like a decade now.
Okay.
So
you're a veteran. You're a veteran. But this year, 13,500 attendees, the largest KubeCon ever. Representatives from over 100 countries.
Yeah, I mean, I think it's really fantastic when you bring the community together and you see all of the great things that are coming out of this, and the companies and across the board, not just vendors, but actual users participating and contributing back, which is fantastic.
It's really a community event, and with that, I would like to welcome fresh from the main stage, we have Robert Shaw, Director of Engineering at Red Hat. Welcome, Robert. And Brian Stevens, SVP and AI CTO at Red Hat. Thank you so much for coming on the show. Back to the show, I should say, Brian.
Show.
I am actually going to start.
I love theCUBE.
We love you back.
You're both veterans now, so I know, it's like, yeah.
That is true, that is true. I'm going to start with you, Brian, because it's a very big moment here with Red Hat contributing LLM-D to CNCF. This is a significant milestone. Let's bring the community up to speed a little bit on what's actually going on and what it does and what problem it was built to solve for.
Well, the whole world's been focused on forever training. Like, all we hear about is like model creation, right? But we never see the impact that those models are creating. So, now we're hearing it's all about inference. Prior to Red Hat, we were at a company called Neural Magic for 6 years, focused on inference. Like, someday inference is going to be important, right? Which is when you actually put AI to work, right, in production systems. And so, what we realize is that AI is being developed by data scientists, and as part of that, they're kind of building their own infrastructure to run it on as well, which makes sense, right? Train it, run it, all in a different kind of universe. But the way we thought about it was, eventually it's going to be a CIO's problem, right? If AI gets successful, and they're going to be the ones managing it and scaling it and operating it. And what language do CIOs speak these days? They speak KubeCon and Kubernetes and Kubernetes-based platforms. So the challenge we had is, how do we build best-in-class inference that's scalable, manageable, delivers to the SLO, SLA that end users need, maximally efficient because the hardware it runs on is expensive, but bring it into a Kubernetes platform that enterprise already knows. So that has been our mission, and that's what LLM-D is all about, is to unify and implement all the core technologies that even the most advanced frontier model server would use, as well as enterprise, and then get that standardized, but importantly enough, get it into a foundation. We started a year ago, but it needs to live in a foundation, and so that was why we're excited about today.
Yeah, and I mean, even just going back, right before NA, going to Salt Lake and everything like that, we talked about this a little bit. It wasn't there yet, and you guys have made some great strides with LLM-D. You're one of the maintainers of it, and so kind of help us understand where it's gotten to from, Salt Lake to today, to being contributed. How have things been going? And because for me, it's a lot about being able to do inference across infrastructure, being agnostic from that perspective.
Yeah, I mean, if you think about what's been happening over the course of the past, even the last 6 months, the demand on inference has gotten huge. If you think about, these modern agentic workloads like OpenClaw or OpenCode, they're just driving so many tokens through every individual inference session. So the need for at-scale high-performance inference has just gone, up and to the right, as fast as you could possibly imagine. And so I think that a lot of companies and model providers are starting to really think about what's that really next frontier of inference optimization that they need to do. I've worked on vLLM, which is the model server, for a really long time, and vLLM does a great job of squeezing as much performance as possible out of an individual node. But LLM-D really takes that to the next level by optimizing a whole cluster of vLLMs to really get the best possible performance, and really targeted at these modern complex workloads of the agents that are dominating the storylines today.
Yeah, and vLLM, just to be clear, is part of PyTorch, which is also Linux Foundation. So it's part of the family from that perspective.
We're all in the family.
Yes, and that would seem good, right? Because we saw PyTorch on stage with you, and
Yeah.
I know it from the OpenStack days because I was a contributor back in those days, and
Yeah, HP was,
it's like my brain hurts every
Yeah.
time I see that, and Open Infra now, and
Yeah.
so when you look at all of these things coming together, do you see this as kind of a really big inflection point? Because to me,
Yeah.
Kubernetes as kind of that operating system for AI, it to me is...
Yeah. I think so. Like we looked at it, like, you know the old thing, like don't ship your org chart. Product companies like shipping different things, and like you don't want to ship your foundation either, right? Like, and so when you think about it, like customers don't see the walls of foundations; they see capability, right? And so when we started, I mean, we've been the top developer contributor to vLLM since its inception, and it was good to see that. It started out at LFAI, found its way into PyTorch, that's good, core thing. But it caused us debate and pause with LLM-D, like do you go over there and do you put it there? Like, so we were kind of like, it needs to be in a foundation, but which one?
Right.
But what we realized in the end of the day, like it needed to be closer to the users, right? Bring the capability closer to where the users are. And the users are here, the users are Kubernetes users, as we were saying. And then it just means that you got to think cross-foundation. You just got to think about like, don't reinvent everything. I think engineers are so good at reinventing everything yet again, but that's ridiculous. So what we want to do here is find the best technologies that are part of building, we call it like models as a service, clouds, or whatever your favorite thing is, inference at scale, distributed inference. And for us, that was vLLM. And what we were able to do when we started LLM-D is, you have to change core vLLM to work inside of an LLM-D system. And we did that, didn't matter that it was in a different foundation. And then all of this stuff in Kubernetes had to change, a lot of stuff in Kubernetes had to change as well, because they kind of dealt at the pod level, and not at a distributed set of pods that have different roles. And we're like, they'll never change. Like what do we do? Like, they're not going to care about this workload, but they did. And so, K-serve, a core technology in Kubernetes, adapted to this new workload. The gateway adapted to become AI aware. So it's been this really cool thing. I'm kind of glad now that all the technologies are distributed across foundations, but coming together as a really, it's a best-in-class solution. And no apologies at all for what this has become, and it's already influencing. You saw Mistral and others. It's already influencing and bringing in capability that a lot of the big frontier models actually didn't have. And so like good for enterprise in the end, right? Because they're going to get to consume all of this.
So break it down for us. How does it actually change for an enterprise running AI in production? What does it unlock that a monolithic system couldn't?
Yeah, I mean, I think Brian hit on this a little bit, but the focus on performance, and really like the reason why performance matters so much for LLM systems is the L stands for large. it really means like these models are doing an amount of compute that's hard to fathom sometimes. Just the overall cost of these systems is through the roof. And not just due to the model size growing, but also due to the workload itself becoming more token intensive. I keep coming back to this agent thing, but it really is driving like orders and orders of magnitude more tokens to accomplish any given task. So performance is really, really, really important for building these LLM services. But when I talk to users of LLM-D, they're not only trying to build a state-of-the-art performance system, they're also trying to do these day two operations once you have things up and running. They need to do rollouts, they need to have it integrated into their networking stack, they need to do all of the things that IT has always done to keep things up and running. And so that's what I really like about the philosophy of LLM-D is we're implementing all of these amazing performance optimizations that are frontier and state of the art, but we're doing it in the confines of a Kubernetes system that's set up for years and years and years to do these types of day two operations that folks have to do to keep the systems up and running. So that's really, I think, why we have a role to play with LLM-D. And
when you think about it, what we're doing is we're liberating both IT organizations that are going to run these, but we're also liberating their end users, right? We all think about like consumerization, right? And we're all using LLMs, and so we're the user in that case. But now you think about like enterprise organizations, they're going to have their own set of users that are going to need model services, right? Some are going to be developers, some are going to be like big uses at scale, some are going to need more real-time. So what they need, what we've designed this around, right, is we started, well, how do we meet a service level objective of what the end users of this capability need? So the whole system is around, you really specify an SLO at the model level that you want. The system delivers on that model level using these advanced algorithms. We give the IT, the SRE capability to manage this thing, right, and have the insights. And the whole thing down at the bottom is, you got to deliver the performance the SLO needs with the most efficient use of the infrastructure as possible. So offloading the infrastructure for faster performance, and actually you're creating more capacity, more efficiency of these really expensive accelerators. So it's really kind of those three tenets.
Yeah, that's where I was going to go, is like understanding kind of the balance between efficiency and disaggregation, and how do you see that playing out? Because like you said,
it's a tool. I know we get into all the algorithms and disaggregation and stuff, but at the end of the day, if you think about it, and Rob did some of this early on, like if you just ran LLM on a single instance, single set of GPUs, single server, like ran it all together as one process, it's really hard to control the SLO and the performance to an end user. Like, we were constantly in just vLLM, like changing, like, okay, we got to deliver more next tokens for different set of users. Oh no, here comes another new prefill, another new job, we got to process all this new input. And it was really, you were always trying to schedule balance. Instead, what we did with disaggregation is we split those apart. And then all of a sudden, once we split them apart, we're like, oh, now all of a sudden we can independently scale like the processing of the input from the production of the tokens. And once you do that, there's a dial on there that an end user, that an IT can say, oh, dial up the performance of the input processing, or dial up, we're not delivering fast enough on the next tokens, dial that up, and then underneath the system uses these advanced algorithms to independently scale them.
You're making it sound so easy. What are you observing about how enterprises are in fact deploying this, and are they trying to do too much at once? And it sounds exceedingly complex too.
Yeah, I mean, from my engagements with various enterprises, I think we've kind of seen an evolution over the course of the past 2 years where maybe 2 years ago, everyone was sort of thinking, okay, open source models are a thing. I need to start thinking about what my platform looks like. I need to start getting access to GPUs, whether it be on cloud or on premises. 2025 was really about setting up all those clusters. So we started to see enterprises having GPU clusters with 256 or 1,000 GPUs. Like, these are pretty significant CapEx purchases. And really, the second half of last year and into this year, all the software stacks have started to get laid down. And so I'm really seeing organizations having two separate models. Sometimes they have some like monolithic deployments that are targeted at very specific applications. Maybe the 20% of the applications that are for the big major workloads that they have internally. And then they have another 80%, which is all different developers across the company are trying to experiment with AI. So they're setting up this model as a service concept, these kind of shared multi-tenant deployments that are being accessed by various different applications across the organization. And so I think we're just going to see the demands on these compute clusters going up and up and up as all of the business applications start to mature, and as these GPU clusters inside of organizations get bigger and bigger and bigger. And so LLM-D and Kserve, which is the CRDs that we use to package everything up to make it easy to deploy, I just see this becoming more and more and more important as the amount of compute and workload that enterprises are running just continues to go up and up and up and up.
And a year ago, like if you look at, because you were asking earlier, like how did it change in a year? It was all DIY. Every frontier model server, every enterprise had to have their own opinion on how to build this and how to do this. Like, because there wasn't the tools, there wasn't a reference architecture, this capability didn't exist. So it was so hard, so you just saw a lot of like, greenfield things that all look different from each other. So it's kind of nice to all of a sudden, the enterprise engagement side of this is like, it's a set of capabilities they didn't know they needed, that existed, that was ever going to exist, and so it's definitely influencing how they think about building AI data centers or AI clusters, smaller sort of size, and then obviously in Kubernetes.
And the other thing is like, the models themselves are getting so much better. And I think that that's just a backdrop over the course of the past 3 years of like, anytime you look at the last 6 months, you can't believe like how much things have improved. And like, if anything, that's just accelerating as these agentic type patterns are starting to become more and more prevalent. So models like GPT OSS are being deployed at massive, massive scale. NVIDIA, obviously at GTC, they're talking all the time about Nematron. I couldn't be more excited about that investment and the community that's going to develop around the next generation of open source models. Like, I'm just so excited about the future, and I think we're going to have a really, really great 2026, 2027, 2028, where open models are just going to get better and better and better and better, and that's just going to drive more and more and more need for enterprises to really be running these models efficiently at scale for all sorts of applications across their companies.
Yeah, and I mean, if we start to look at it, and as we kind of bring this to a close for this time here, and I know, it's like, it goes fast, doesn't it?
Warmed up.
I was going to say, it goes real, as you've learned before, this goes real fast, and it's like over in a snap, but as we look out towards Salt Lake and everything like that, what do you see, or, what do you hope to see out, that's what, almost 8 months from now, so about 8 months from now, we'll be in Salt Lake. What do you hope and what do you want people to know to get involved? Because to me, part of this is bringing the community together to help you guys build better, right? And as part of it.
Yeah, I mean, I think in the LLM-D model serving, kind of space, we obviously have a really exciting roadmap to continue, driving innovation into vLLM and into the distributed inferencing layer. So we're going to continue investing in the key items we have already. I'm really excited about some new features that are kind of more focused on this multi-tenant model serving stuff, which is a little bit focused more on like request prioritization and how do you interleave paid and unpaid users or like critical and non-critical applications. So we have like a really great roadmap, especially for kind of these like multi-tenant model, like that second deployment pattern that I talked about where all different applications are consuming the same. And then of course, like the new hardware that's coming in, whether it's NVIDIA GB200 and soon to be Vera, like there's lots of really cool stuff we can do on these kind of new rack scale architectures. Of course, we're working closely with AMD, with Google, with Intel, on other hardware accelerators. So we're continuing to really push on that. And then I'm really tracking what's going on with agents. Obviously, we've seen OpenClaw and OpenCode as some examples of applications. There's lots of security challenges associated with those types of things, and I think a lot of the solutions to these are going to be things in Kubernetes, whether it's sandboxing or at the networking level associated with permissions, identity, access control. So I'm really keeping my eye on that and making sure that our inference stack can fit in well there. But yeah, those are kind of the main things. Like the model serving stack needs to keep pushing, needs to keep up with all of the new innovations in hardware and these new patterns associated with this multi-tenant stuff and the agent space. I have no doubt that it will be very dynamic. So yeah, it's going to be a fun next few years.
You're going to be busy. Let's put it that way. I think you're going to be very busy. But yeah, thank you. That was great.
Thank you. Your enthusiasm is infectious. Thank you so much, Brian and Robert. Stay tuned for more of theCUBE's live coverage of KubeCon and CloudNativeCon EU. I'm Rebecca Knight for Rob Strechay. You're watching theCUBE, the leader in enterprise tech news and